recording of your presentation, and I give you the host. Okay, you are co-host.
Yeah, I'm able to
Maybe I give you
share
host.
now.
You will give the you host because you will break out the room as well.
Okay.
Yeah. Okay. So the next you can I will quit sharing and yeah.
Yeah. Okay. So this is the EEG-based emotion classification project that we are offering for Stage 3. So the background of this project is that uh, we want to use machine learning techniques to identify the emotion of human emotions based on their EEG signals. The significance of this type of research is that traditionally when people meet other people face to face and want to understand their communication, one of the important thing is that we identify the emotion, and we can do that by reading other people's body language, their facial expressions. In quantitative ways, we can do surveys, questionnaires, interviews. But due to language barriers and the unclarity of emotion itself, it is really sometimes it's hard to grasp the actual emotion. And more importantly, um, when we're talking about human and machine interactions, emotion is another important thing to improve the communication between human and machine.
Hi, Kari.
So
Kari, I'm
yeah,
not sure. I'm very clear to hear you. Someone said like its voice is not clear. I'm not sure it's
that was for you.
it's me. Sorry. I mean, try to close, but today I'm not sure. Internet seems not very well. Yeah, sorry. Maybe continue. Sorry, Kari.
Yeah, it's okay. Yeah, it's
Yeah.
okay. So yeah, so in this project, we're going to use EEG signal, which is the electrical signal collect from the scalp to actually detect the human emotions. And the first thing, before we actually jump into signal processing and classification, we need to um, sort of identify what are the emotions that we are going to classify. Normally, we consider emotions as sort of discrete categories like happy, sad, calm, or depressed. But that way, we can't really use our engineering background or our mathematical models to do classification. So the first thing we need to do is we need to put these individual emotions into numbers. And this graph, and it's a simplified Feldman's model. This graph shows that we can actually put the emotions into a sort of a XY plane. The x-axis is valence, and the y-axis is arousal. So when you have high valence emotions, you tend to get emotions like happy, content, and in median you get delighted, relaxed, and in neutral sort of sense is more calm. And when you go to negative, it's pretty much your negative emotion that becomes depressed, frustrated, and in arousal, the high arousal means you're more intense. So that means sorry, intense and more excited. And the lower ones means that you're tired, you're calm, and etc. So in this format, we can actually give all the emotions a number to represent it, and the database that we gave you and we recommend you to use is deep data sets. So this, um, just a sec. So this website is called Deep Dataset. It's a dataset that um, collecting EEG signal and ask the participant to rate their emotions. So it is a pretty good data set and it's free to download. So if you just go to download and send a request to them, they will reply really fast. So usually within 1 or 2 days, we'll give you the access to download the data. It has the very raw data in Excel form, or they have pre-processed data in MATLAB form if you want to use MATLAB, or in Python format, so you can use Python. And I think this is a pretty good data set to work with. You don't, in this stage 3, since the time limit is only a few weeks, you don't really need to go through all the data in this data set. Maybe just choose 1 or 2 people to do the classification should be good enough.
So, Carrie, they also
Yeah.
have a video I have seen. What's the video? The
The video is they capture the videos while
doing
the
exercise.
participants are doing the experiment.
Okay.
But that's mostly for facial
Recognition.
movement recognition. So it's a little bit different than EEG, and it's slightly more difficult.
Okay.
It requires you to do some time series analysis as well. So I recommend we just stick on the EEG for now. If you're interested, we can definitely give you more information about these facial ones. I have worked with other researchers on combining the face video with EEG at the same time to improve the classification accuracy. So yeah, now if you want to talk about more, we definitely can. So okay, let's back to the instruction of our stage 3 project. So this is a flowchart for this project. At the start, we have the dataset, we download the dataset, and we separate the dataset into training set and testing set. The training set will help you to train the classifier. And after we check our classifier and we make sure the classifier is working, and we go to performance testing while we're going to use the testing set and get the final output. And this whole thing designs the classifier, which can be used later for emotion classification. So something that we are more familiar with is that when we download the data, we will proceed with signal processing, and that's what we have learned in this subject um, in the first couple of months. So we will do spectral analysis, we'll do filtering if you download the raw data, and even if you download the pre-processed data, you can still do filtering. Depends on what type of application you are gonna use. Um, Next, we can segment the signal. Uh, then, with the segmented signal, we'll do feature extraction, which um, can be categorized into two domains, in either time domain or frequency domain, or we can do both. In time domain, it's quite simple. Max means standard deviation, variance, and those sort of statistic ones. The frequency domain features includes fast Fourier transform, and some things we learned in stage 2 are short-term Fourier transform, um, continuous wavelet transform, and discrete wavelet transform, and many other frequency domain features as well if you want to explore more information. After that, we go through the classification part, which is this part. You will learn this machine learning classification techniques next week, but it's actually quite simple in right now, because in MATLAB, um, I think from MATLAB 2016, there is a app called Classifier Learner, and you don't really need to type your own um, scripts for your machine learning algorithm. It's a quite simple app to use. You just need to load the testing data set and training data set into that app and select the algorithms that you want to use, and it will pretty much train and test it for you and generate the raw curve. As long as you can read the raw curve and understand what the ROC curve means, then you can. That's pretty much all you need to do in this classification part. And after you get the result of your classifier, you can develop a more detailed discussion for this project. A few points I've wrote here. You can talk about the quality of the EEG signal, and do you think is there any other ways to improve the part where you collect the signal itself or when you do the experiment? Another thing is you can talk about the signal processing techniques that you implemented. You can talk about the classifier design and the overall sorts of the project. So I think it's a pretty um, uh, systematic way to learn a BCI or brain computer interface project or human machine interface project. So it should be a quite good opportunity to start from this um, emotion classification project. So that's what I offer for stage 3.
Okay, thank you, Corey. Maybe next is Jeffio. Hi, Jeffio.
Yeah, I'm here.
Do you want to you be the host?
Sure. Yeah.
Maybe Corey will.
Oh, Kari just give me multiple people sharing. Yeah.
Oh
Okay.
yeah, that's okay. That's
Yeah.
okay.
Okay. Got it.